It's space weather. I'm your host, smAsho, and here's the sun at 193 angstroms. We see 0 sunspots, a new coronal hole region rotating in south of the equator, an active region north of the equator, not to be confused with a sunspot. And we got 21 tabs open, so no screwing around. Here are the magnetic lines. There is also an incoming coronal hole wind stream currently. Before we go on with further data here, our #1 officially endorsed channel here, hosted by Dr. Pierre-Marie Robitaille, has released a new video on the Herouni antenna. Now, as our regular viewers would know, Robitaille is famous in the electric universe community. He's somebody who's been debunking the cosmic microwave background since the science came out on it. There is no evidence of the Big Bang, and here's another way to debunk it. Take it away, Dr. Robitaille.
There was no Big Bang. You can learn more about Herouni's measurement in this paper, which is also linked below. Herouni should have had a total signal of about 6 Kelvin, with some signal coming from the cosmos, but the signal was just not there. So he sent his data to 10 of the world's top laboratories and asked them to highlight potential errors in his measurements. None of them replied. Of course, there was no error.
Anyway, we'll leave links to that video. Recommend you have a watch. In fact, watch all of Sky Scholar's videos. They are beyond enlightening. And here are some additional photos of the Herouni antenna. It's been decommissioned. Robitaille is looking to get it recommissioned. Let's do it. Next, we'll have a look at the real-time solar wind here. We see it is elevated, significantly elevated. Now, the BTBZ is fairly convergent right now. Nothing too major going on with that. Or the phi angle. No sun-to-earth connection, apparently. However, the density remains pretty high at 5.87, considering that the wind speed is still 568 kilometers per second. Also, note the bottom pane. We don't look at this much, but you can see pretty wild fluctuations in the temperature of the solar wind there. Moving on to spaceweathernews.com. See a tiny little X-ray flux there. Nothing reaching into the B range. Some magnetometer perturbances there. See this? This has to do with these dense and diffuse regions on the corona. We'll look at it in a moment on the Gong 2. KP index remains elevated at 3, just coming down from 4. Now, we've actually for a short period entered into electron storm territory there, but that came back down. I would be expecting another dip in this electron flux like this one. But that's something to keep an eye on today because, well, it's not behaving normally. Also, we see some charging hazards here, some surface and some internal charging near the equatorial regions. The F2 ionosphere layer is looking what we've been referring to as normally anomalous. There's your aurora forecasts. The auroral ovals are pretty large right now. Moving on. Shout out to spaceweather.com, the site I originally used pretty much for all of my sun information. Check out the auroras. That coronal hole wind stream is sparking some good ones. And there's a nice example. Located in Manitoba, Canada. 10.7 centimeter radio flux. Still at 72. Next, we've got the Gong 2 Global Oscillation Network group. And you can see the cause of these magnetometer disturbances are these areas here. You've got more of a direct and then more of a diffuse. Plasma bunches up here. creates diffuse fields that don't connect as directly to the sun. And that's why we see these changes in the magnetometer. Let's let that play through. Notice that the magnetic connection snaps across, and the magnetic connection itself can move and do unexpected things with no warning. Next, we've got magnetosphere movies here. First, the velocity. You notice the waves of different solar wind speed coming in from the left of the frame there, and the effect on the magnetosphere. Next, we'll look at density. Some minor density disturbances around the Earth there. And lastly, we'll look at pressure, noting that the magnetosphere is pretty charged up right now thanks to that incoming coronal hole wind stream. Let that play through before we move on to geospace ground perturbations. Here we've got your ground perturbation changes here from the poles. Some quite interesting stuff going on there. There's like a field separated from the South Pole there in between Australia and Antarctica. And we've got all kinds of magnetic field coming out of Hawaii. Let that play through a second time because there's a lot of information to see on that. Gonna let it go through twice. And by the way, there has been an uptick in earthquakes. Over the past about 3 days, and we are still having a drought of 7+ earthquakes. Let's look at some of the aspects of it here at quakes.globalincidentmap.com. You can see there's a significant uptick there. Now let's start out at the Dominican Republic. There's been a swarm going on there in the ocean, in the Caribbean Sea there, in between Puerto Rico and Dominica. Some deep quakes happening. This one's not, well, it's 89 kilometers, so it's kind of moderately deep. I see some quakes happening in Alaska. Basically, the entire west coast of South America and North America getting hit by earthquakes. Guatemala, 4.3, a 4.2 in India. Zoom out, show you the location of that one. Did you feel that one, Debine? I don't know how close you are. Got a 5.5 in the West Chilean Rise. There's that location. .9 in Japan, 4.7 in Indonesia, 4.5 in Tonga, at 354 kilometers, by the way. 4.4 at depth at Chile, raising the earthquake risk there, especially when the next coronal hole magnetically connects to the Earth. There's another 4.8 at Chile, a 5.0 at Ecuador at depth, 100 kilometers. So, earthquake uptick. We're not even done yet. Where were we? Also a 5.1 in Alaska, the largest quake they've had there for a while. Where's this one? Out at the tip of the Aleutians there. Out in the Bering Sea. New Zealand, a 4.3. and a 4.9. South Sandwich Islands, a very far south quake, ends the list of significant quakes at a 4.6, all the way down toward Antarctica. Got a new volcano on the list, too. So let's go to volcanodiscovery.com. So we've got Shivaluch still explosively erupting with a 15,000-foot ash plume. Sakurajima, no volcanic ash identifiable in satellite imagery. Perhaps a downtick at Sakurajima. Karangatang in Indonesia is the new one on the list here. $8,000-foot ash plume. This volcano last erupted in 2015. All right, moving on. Karangatang. Say it aloud. You know you want to. Tukono, 7,000-foot ash plume. Popocatépetl, sporadic emissions of volcanic ash. Fuego, volcanic ash emissions. And Reventador, producing a 16,000-foot volcanic ash plume. Now let's look at some bigger things. Scaled map transient analysis for Sagittarius A star. For those of you who are not aware of what Sagittarius A star is, that would be the core of the Milky Way galaxy. A massive radio source located at the center of the galaxy. And we don't really see any big transients in there. Although the largest one in 2019. Anyway, here's the point. Largest emission ever was just before New Year on 2011 to 2012. And the second largest emission would have been just before New Year 2017. Anyway, we'll leave links to it if you want to watch the emissions of Sagittarius A star for yourself. Next, we'll look at some other radio sources. Cygnus X3, this one's from inside our galaxy here as well. Cygnus X3 is probably our favorite radio source there. It becomes a North Star known as Deneb, the tail of the swan in the constellation Cygnus. It's a high-mass X-ray binary is the official classification. It's been called everything from a blazar to a microquasar to a black hole to a neutron star to a... who knows? We just call it a radio source. Anyway, no big transients out of that. However, I would note that the third largest transient ever measured was right before New Year. The largest transient ever was at the last solar minimum, and right around when the highest cosmic ray flux ever measured happened. And second largest one was back here, and that correlates to absolutely nothing. Next, let's look at the second most powerful radio source in the sky, Cygnus X1. And Cygnus X1 has been ramping up. Check it out. It must have heard about Sagittarius A star's New Year's Eve party and decided to throw one of its own. For those of you who aren't familiar, Cygnus A is a radio galaxy. Let's look at it on the Chandra X-ray scope. Anyway, here's some more images. Just to give you an idea, it's actually a very large galaxy, counting those radio lobes. And here's a pretty new article about it, actually, on the Chandra X-ray Observatory site. Now on those radio images, these are the radio jets coming out like this. And what we're seeing is we're seeing a hole punched in the gas and then a hot spot forming, because that's where a condensation reaction can occur and create a star forming region. So anyway, another interesting article about the second most powerful radio source in the sky, Cygnus A. Correction, the last one we looked at was Cygnus X1. That's the famous, quote, black hole, end quote, in our galaxy that Stephen Hawking and Carl Sagan famously bet on. Cygnus X1 has an uptick since 2019 began. And here is the transient analysis of Cygnus A, the radio galaxy. Sorry about that. Confused Cygnus X1 and Cygnus A's transients there. You see, this is a very reliable radio source. The historic data here, we get lots of signals from this. And as far as 2019, no uptick going on there. And again, that last transient that we looked at, that was Cygnus A, the massive radio galaxy. Second strongest radio source in the sky. Now for a quick rundown of cosmic rays. Here's Athens. Not a lot to comment on, small uptick there. Here's Mexico City. There's Moscow. And we'll close out the cosmic ray data with Oulu, Finland, DOMC Antarctica, and DOMB Antarctica. There are your cosmic rays for the reliable sources. Next, let's talk about presidential candidate Spartacus, Cory Booker. When you hear me on TV saying you need to be reined in, what I'm really saying is, I love you. Oh yeah, that's right. Cory Booker apologizes to Wall Street bankers for the mean things he's going to say about them. Sighing with resignation as he spoke to those surrounding him, Democratic presidential candidate Cory Booker reportedly apologized to a coterie of Wall Street bankers Friday for all the mean things he's going to have to say about them in the upcoming months. Things are liable to get a little ugly out here on the campaign trail, but if you ever hear me attacking you guys, just know I don't really mean it, okay? Wow, it's an awfully serious article here. Hey, Cory. Good luck, Spartacus. Good luck and Godspeed. Lastly, you ever heard of Harrison Schmitt? Well, I didn't until yesterday. Anybody know who Harrison Schmitt is? Harrison Schmitt is the last man to walk on the moon. That's right. American geologist going up and collecting glass from the moon's surface. University professor, NASA astronaut, and former U.S. Senator from Mexico. I discovered Mr. Schmitt while listening to the rantings of Norm Macdonald, one of my favorite comedians and pure genius. Anyway, if you're not familiar with Mr. Schmitt, he's a huge climate denier. He doesn't believe that man-made CO2 emissions have anything to do with temperature. Good for you, Mr. Schmitt. Well done. Well done. Next, let's check up some other views here. 304 angstroms. See a big filament in the southwest. I don't think it escaped into space. That large filament we were looking at yesterday in the southeast looks like it is actually headed up this way. Let's check out 171 angstroms. See if we can see anything going on with that filament down there. Right here. Take a close-up of this active region. Not a sunspot, folks. There's no dark umbra associated with that. But we'll be keeping an eye on it. Remember, when you're looking at active regions rising during a coronal hole wind stream, don't drink. And if you drink, don't drive. And also, death to the Patriots.